All right, so we're going to start exercise number 6. This is the last exercise in this lab, and it's pretty straightforward. We just, instead of one solenoid, we're going to play around with 2 solenoids. So let me show you how I set it up. The solenoid on the left is going to be my primary coil. Now, this is what we talk about when we do talk about transformers, because I'm basically making a transformer. I've got one solenoid, and it's hooked up to the power supply. So you can see the leads are going right to the power supply. Now, we're going to use a lantern battery later on, but right now I'm using the power supply, and I've got it hooked up to what? DC at first. So what I want to do is turn it on and put it at 3 volts. 3 volts. All right. So it's about 3 volts. Now, I've got it hooked up to DC, 3 volts to the primary. Now, the secondary is not hooked up in any way to the primary. I do have a voltmeter across it, so this lead right here and here, that goes to my voltmeter over here. So what I'm going to do is turn on my voltmeter and measure different settings. So right now it's off. I've got the leads on the positive and negative. I'm going to move it first to VDC. And on your data table, when the primary has a current of 3 volts going through there, nothing is being picked up on the secondary. Now, when I say nothing is being picked up, they're not connected at all. Why would anything come out in the secondary when it's not hooked up to the primary? So that is the idea of Faraday's law of induction. When this current is steady and you have a constant magnetic field, there is no current produced in a loop of coil nearby. Only if the magnetic field changes or the area changes of the loops, which we're not going to change the area. We're just going to change the currents. So in this case, the magnetic field is constant, no pickup at all. You can see that from here. Now, just to make sure, I'm going to put it on volts AC, and you also can see that it reads 0. Okay, so both of them read 0, and that's to be expected because there's not a changing magnetic field. So what I'm going to do now is I'm going to turn off my machine and switch the leads over to AC. Oops. One of my leads just popped off. My voltage leads popped off on my... Okay, got it back on again. All right, so now I've got it on AC, and I've turned it back on. I'm going to now move it to 3 volts AC. So 3 volts. 1, 2, and 3. All right, a little more than 3. So again, I didn't change anything. I have 3 volts AC. Now, when you have AC current going through something, the current's constantly changing, which means the magnetic field is constantly changing. And so what we're going to do is we're going to look at the voltmeter again. On DC, it picks up nothing. Again, that's because it's looking for a steady voltage. The voltage is continually moving up and down, up and down, up and down, so you're not going to read anything on here. However, if I switch this to AC voltage, I get some pickup. I get about 3 millivolts worth of pickup. And that's when the meter is set. So that means this secondary energy is being created in here. And it's being created because of the change in magnetic field that's created from this one. Again, remember, we can't see magnetic fields, but the magnetic field lines are coming out, and they're coming into some of these coils here. And because the magnetic field is changing, it's inducing a voltage on that coil. Now what I'm going to do is make that induction stronger by putting the iron bar that we saw before. In a regular transformer, an iron bar is put between the 2 wires. Again, it's not connected to anything. It's just there to strengthen the magnetic field, to strengthen the flux. Get it in there. All right. So what I'm going to do now, it multiplied it by over 10 times. Do you guys see the difference when I put the iron bar in there? The voltage pickup went up more than 10 times. Huge. That's actually a really big effect. So the reason why those big black boxes, those that you have on your computer that you plug into the wall outlet, that's changing from AC to DC is also changing the current. It needs some iron in there to make a better transition, a better pickup. So if you don't put that iron bar in there, you get very little pickup. The iron strengthens the magnetic field, and the change of the magnetic field is able to penetrate a greater depth into the secondary solenoid, and you can get to pick up more voltage on that one. Okay, so that's with the AC. Now what I'm going to do is turn off this power supply. And instead of using that power supply, I'm going to use this 9-volt battery sitting here. Oh, sorry, it's 6 volts, isn't it? It's 6 volts. It's called a lantern battery. And I do have a lantern, a really big flashlight that uses one of these things. So every once in a while I have to go to Home Depot and get one of these fresh ones. This thing isn't very fresh though. So what I'm going to do is, instead of having the leads go into the power supply, I'm going to put them into here. Now I don't really need alligator clips. I'm just going to kind of do this because there's springs on here. I'm just going to stuff them in like this. And so first of all, what I'm going to do is stick them in so I get a constant DC voltage. So I have a constant DC voltage through here. And what pickup do I get? If I change this to DC, I get 0. Now, if I change it to AC, I get a tiny little pickup. The reason I get a little pickup that way, because there's a time, it was actually really high before when we had it in the previous setting, and it takes a long time for this to go to 0 because of the way the AC meter is set up. If I got a fresh new meter that's been sitting for a long time, then it'll read 0. But notice how it's going down. It'll eventually go down to 0. That has to do with the capacitors within this body. It takes a while for the capacitors to get discharged. So what I want to do, I'm going to do now, is I'm going to take this negative lead off, and I'm just going to flick it like this. And while I'm doing that, let's go see what happens to the DC voltage. So I'm going to tell you right when I'm starting to disconnect and connect. So all I'm going to do is go like this. I'm going to disconnect and connect, disconnect and connect really quickly. See if we get any. All right, I don't get anything on my DC voltage. Let's see if I can get anything on here. Yep, I do get something. You can hear it. What I'm doing is I'm making my thing go on and off like this. And what that is doing is it's changing the magnetic field inside the solenoid. Now if I stop it, then it'll go back down to 0 again. So now it's going to decrease to 0. So as long as the magnetic field is changing, I'm going to get some pickup in this coil. So that's the idea of Faraday's law of induction. Okay, so I think that's it for this exercise. And he filled out the data sheet. So just review what Faraday's law of induction is, and you'll be able to answer the questions. All right.